Good evening. Can you hear me? Hello.
Yes, I can hear you.
Okay. Very good. Just wait for a moment.
I have sent you the chapters.
Yes. I got this. You have sent me the chapters and also these are what it is, the copies it is actually done in your school.
Yes, but biology nothing has been written yet.
Okay. So these are what is written. What do you mean by materials? Mention it types of. Uh, okay. This is from which chapter?
This is from chemistry.
Chemistry, that's the sorting thing, right?
Yes.
Okay. So the sorting that in that chapter, what you have, let me just check for real quick. Okay. So that solubility thing and mixing and all of those that we have already studied, right? Almost
Yes.
most of them are already studied. We are actually talking about different kind of materials and matters, right? Now,
Yes.
you have idea about matters. What is matters? You know,
Matter means a fixed substance.
matters means what?
Fixed substance.
Can you explain like what does it mean?
Means the mass of something.
Um,
Volume.
yes. Do you know what is mass and what is weight?
I know what is weight.
What is weight?
Means weight is the thing which we use to means see what how much something weighs.
It is actually the mass and weight. They're actually very close. Like both of them, we actually express them in kgs and grams and units like that. Units we already know, like the standard unit and idea about units. What are those? We already have those, right? Now they're kind of similar, but they're obviously very different. Now matter is what is inside something. Take for example, take that pen, right? It is made out of something, some plastic is there, right? Now obviously there is an empty space inside that. Now inside that you have a refill and it is also made out of something. Inside that you have the ink and some air, right? So these are things that makes object. Or take for this, charging brick, right? uh, Also it is actually made out of something, right? So whatever it is made out of, it is actually it's matter, right? Something is making that particular object. Now whenever matter is everything, like whatever we can actually touch, we can see, we can observe, that is actually matter, right? Now the close, let's look at a definition of matter. um, See, uh, physical substances in general as distinct from that is, forget about that, which takes some space. Okay, anything that will take space, that we can actually touch, that we can actually interact, that we can uh, measure also. These are all the matters. Like the plastic is a matter, uh, metal is a matter, even a liquid or water, that is a matter, even the air that we cannot see but we know that it is present because we can actually interact with it. These are all matter, right? Now some any object is actually made out of some matter, right? Now the weight and the mass, they're kind of close, right? So whatever matter is making a particular object or something, it is actually mass, right? How much of that substance is making that object, right? Now that object is actually pulled by the gravity. Gravity, you know what is gravity?
Yes.
What is gravity?
Gravity is the thing which we means can stand. Without gravity, we will be floating in space.
Yes, like it is, if anything is there, if any object is there, it will attract other object. Like the earth is a very large object that is actually floating in the space. Now we are all living on the earth. Now if you keep it like that and if you do that, it will fall. Because why? What is actually pulling it in the bottom? The earth is actually itself pulling it in the bottom, right? The earth is actually pulling it towards itself, right? Now that is actually the gravity. Now whatever a matter is, like whatever an object is, it is made out of some matter. Now that matter, that object is actually pulled by the earth itself. The earth is actually pulling it towards it. Now that if we multiply the force through which the earth is actually pulling it to how much matter it is made out of, we will be getting the weight, right? So that means what? The weight is actually different in different places. Like if you measure your weight on earth, it will be a value. Obviously, if you measure your weight on moon, the weight will be slightly lesser. Not slightly lesser, it will be 1/6 of your weight on the earth, right? Because how much force it is pulling the matter, it actually a very important part of the weight itself. But the mass, it will remain same. Like the matter that makes you, it is always same wherever you are measuring. Like you are measuring on the earth, the mass is exactly the same as if, when you are measuring on the moon, right? It will not change. So now matter we have understood, like there are different kinds of matters, like wood is a matter, metal is a matter, the liquid, water is a matter, even a gas or the environment or the air we are observing, we can interact with, that is also matter, right? So the chapter that you have, it is actually about the sorting and all these things. It is actually about matters, like how the things are actually made, right? So the very first thing that you have in this chapter, let me get that thing. It is what? It is actually some properties of those matters, right? Uh, okay. The very first thing that you have given, like depending on what matter a particular object is made out of, we can actually separate the objects basis on the basis of that thing. I like you have multiple things like laying on in front of you, like some keys are there, some coins are there, some pencils are there, some pens are there. You can actually separate those objects depending on what matter or what material they actually made out of, right? Like if I give you a task to separate all those things that is made of metal, now you can actually do that because you know what is actually metal, right? Now how you can know what a metal is? You know some features, some properties of that the metal shows. Like the metal will be shiny, the metal will be, you know,
Metal will never float on water.
metal will generally not float on water. Metals are generally solid. Metal, if you uh, know, do that thing with the metal, it will create a particular kind of sound. That sound is different from the sound if you do that thing to a wood or something like that, right? So these all are the properties of metal, right? And now also, if I give you some metals, you can actually differentiate between those metals. Like if I give you irons and coppers, how will you differentiate between them?
I don't know.
Like if you have irons and the coppers, you can use the magnets, right? The irons, they will be attached, attracted to the magnets, right? The iron actually, they are attracted to the magnets, but obviously the coppers, they will not. You have seen a magnet, right?
Yes.
These are the things that can actually attract the ions. Mostly the irons and other magnets, they're attracted to the magnets, right? But the copper or even other non-metals like the plastics and all those things, they will not be attracted to the magnets, right? So that means what? The materials that get attracted to the magnets, we can actually call them are magnetic materials. Okay, so the property by which they are getting attracted to it, we call it magnetism, right? Now you have understood what is magnetism and what is magnetic material, right? No,
Yes.
no problem with it. Uh, Now another thing that you can observe, like metals can actually, conduct heat much more quickly than the non-metals. Or say, for example, the woods. Right. Now, a simple example experiment you can also do that. If you have a metal rod, if you do it like that, if you rub against your arms, it will get hot very quickly. Now, if you have a pencil and you are doing the same thing, it will take some time to get warm. Right? Because why? Conductivity means what? Conduction or transportation or movement. The metals, they have that property to move the heat very quickly from one place to another place. The woods and all those non-metal things, they cannot actually do that thing very quickly. They need some time before they can actually do that. Right. So that is how the metals and non-metals, they are also they can be different. And also what? Some metals can transfer heat or temperature, the hotness, quicker than the other materials. Right. The copper can actually do that very quickly, and gold can also do that much quicker than the copper itself. Right. So depending on the heat capacity, right, conductivity of the heat, we can actually differentiate between the metals and non-metals. And also what? Melting points, you know what is melting point?
Melting point. Like wax melts at a point of time.
Like that, what does that mean?
Means it from solid form it will turn into liquid
Very
form.
good, very good. That means for anything, any matter, it has mainly three forms, like solid, liquid, and the gas. Right? Anything can be converted in between into these three stages. Like if it is a solid, if you heat it at certain temperature, it will convert into liquid. If you heat the liquid, again it will convert into solid. Like it is also very clear for the water itself. Like if you freeze the water, it will turn solid. Now what we call the solid water, we call it ice, right? If you give the ice a little temperature, it will convert into what? It will convert into liquid water. Now it's water. If you give more heat to the water, it will turn what? It will turn to vapor, right? The water vapor will produce. But depending on different temperature, the different stages or different phases or different types of materials you can observe, right? So the melting point at which temperature something melts or converts into liquid from a solid, that is much more higher for the metals, right? And for the woods, that thing is completely different. Like if you heat a wood, it will not convert into liquid, right? Because wood is made out of multiple type of particles, like not particles, multiple type of materials. There are different type of materials that makes a wood. Wood will completely burn, but the metals, to make them liquid, it will take huge amount of temperature, and that is the reason that uh, think that the utensils that we use for cooking, they are mostly made out of heat, because they can get hot quickly because they are very good conductor of the heat, and also they don't melt. Like during the cooking, if the pots they melt, it will be devastating. But that doesn't happen because the pot, they can actually withstand that huge temperature at which we can actually cook, and also it can get hot quicker, so that it takes a very less amount of time to cook. Right. So all of these things, that is also very individual property of the materials itself. Like that's why they're called the good conductors. And one material that is not conductor, we call them what? We call them insulators, right? That cannot conduct heat or also electricity for that purpose very quickly. And that is the reason in most of the cases, wherever you are using a metal utensil, you will be having a plastic handle, right? The plastic handle, or in some cases, the handle may be of wood. These handles are there to protect your hand, right? Because why? If you put that pan or put that utensil on the burning fire, the fire is actually providing the heat. The materials that makes the pot, the utensils, that is the metal, it will get hot very easily, very quick, right? But if it gets hot, ultimately it can burn your arms also, so that your arms don't burn. that part where the handles are actually folded by those plastics, which will not turn hot very quickly, right? So that is also another property of the these different materials, conductivity and the insulator, the conductors and the insulators. Those who actually quickly transfer temperature, they are called the conductors. Those who quickly transfer, they are the good conductors. Those who doesn't conduct very quickly, they are the bad conductors. And those who conduct at all at very very easily, they are the insulators. Right. So there are different insulators. Like the cloths we wear during the winter, they also have the same kind of purpose. Right? They actually, why do we wear woolen cloths in the winter? Because we want to trap the energy close to our body so that our body doesn't get very cold. Right? And so that purpose, the woolen cloth, they actually acts as a insulator for the heat. So that body temperature even in the body doesn't get very cold quick. Right? So that is the idea about the conductors and the insulator, and why there are some materials, some most of the metals they are very good conductor and some are not. That is also a wonder. Like, and there is a single, there is a, not a single, there are some metals that remain cold in the room temperature. What are those?
Um, Plastic,
Metals.
metal,
Name a metal that will be cold in the room temperature.
iron,
Iron is not cold. Iron you can get solid iron, right? To make a iron, you need to heat the iron. Very hot you have to make it. And when it is very hot, then only it will melt to create liquid iron. But what metal is liquid in the room temperature?
I don't know.
Mercury.
Okay.
And why do we use mercury?
We use mercury. Um,
Which instrument?
when something is too cold, means too hot, we lay it out so that it can be cold.
No. Mercury we actually use in some medical instrument. What is that?
A stethoscope.
No, in thermometer. In thermometer, have you seen a thermometer? There is a shiny bottom of a thermometer. In that container, there is a container like thing. There is marker, right? When you are putting that thing under your lip or any body part, it will actually, your body is actually giving that mercury heat, right? And anything it will give heat, it will expand in size. It will get large. Its volume will increase, and so does the mercury. When its volume increases, it actually flows through the tube, and how much it is increasing we're actually measuring, and we correlate that increase with the temperature, right? And that is how the thermometer works. And that thing also, and that mercury also used for some uh, you know blood pressure measurement instrument, like that we call the sphygmomanometers, right? We call it the sphygmomanometer. So these are the different use of metals, and how different plastic, glass, and bamboos, and all of those things, they are non-conductors. They also have their different, uh, you know, uh, different properties, heat properties. Okay, so these are all things, and uh, also one another property that you have there is what? Roughness. What is roughness?
What?
Rough.
When something is really hard to touch, means it is very it when we touch it, our skin gets very sensitive.
Kind of like that. The opposite of rough is what?
Soft. No,
Softness.
smooth.
Smooth or soft, both you can say. Soft means what? Soft means you can fold it, torn it, you can crumple it like that. They can be molded very quickly. They can change their shape very quickly. Right? They are also smooth on the surface, like a petal of a flower. Flowers they are smooth. Most of the flowers they are smooth. Most
Yes.
of them. But some flowers they also have some hairs like things on their petals, and that becomes rough. But say for example, if you have taken a brick, a broken brick from the ground, now you are doing that thing on the surface. Would it be feel very soft?
No.
That is also a property of the material that makes it, right? So what we are actually learning in this chapter, we are learning different properties of different materials. What we need to learn that for? Like these are the very basic type of properties that we will be correlating in the future class or in the future chapters with different type of things. Like it will be used for grouping things. Like grouping things mean metals we have understood, like the metals they will have some kind of properties, and depending on that properties we will be grouping some metals together. The non-metals or the plastic and not plastic, like the zincs and the other things, not zinc, whatever, sodium, potassium, this kind of things, they will show different kind of properties. Depending on their properties, also will be actually grouping all those things, right? So this is we are actually learning how to group, how to create a mental model to differentiate between different products, right? So that is what we actually learning. Right. So the another property, like now in a book, what you have given, there is an example of rocks and the flowers. They are different in terms of their roughness. The rock, obviously, they are very porous surface. The surface is not very smooth. The surface is rough. And what the flower, it is obviously smooth. It is good to touch. You will feel good when you touch it. Right. It is smooth on the surface. Right. These are the different properties of the materials. And the next thing that you in your book it is given, it is a last year. What is last year?
Let's the thing which used to make jewelry.
Now, like why we use metals for our jewelry? What is the basic property of the jewelry?
Um, I don't know.
If you look at the most of the jewelry, if you look at most of the jewelry, they shine,
Yes.
right? And that is how they attract us. The more they shine, they will attract more. That is why a diamond is much more precious than any other stone because it shines very well. The gold it shines very well than a copper. That is why the price of the gold is higher than the copper, right? That is how all those things works. So last share is a property of the the metals, the materials that makes them their brightness, their shininess, right? That property we are calling the luster. The metals, they are generally shiny, very, very shiny, very metallic thing. And just by looking at the luster, you can say if that thing is metal or not metal. If there are iron, copper, zinc, and also plastic, bamboo, wood, just by looking at if they are shining or not, you can say which one is which one is metal and which one is not metal, right? So that means what? Just by luster, that is also a very important property to identify or group things together, right? So that is also a very unique property, a very important property, and the luster is a very easily can be observed in the in case of the metal. Now the next property that you have, it is the hardness. What is that?
When something it is hard and it also has weight in it.
It is not very well, not very easy to bend, right? It
No.
is it is weighty. It has huge amount of mass. It is heavy, right? So all of those things makes it much more what you call much more hard, right? And the opposite is soft. That can be bent very quickly. That can be broken very quickly. That can be torn from the middle very quick, right? They are actually soft. That hardness and softness, that is also very unique property for different materials. Like obviously the metal should be much more hard, right? Generally the metals they are harder than other things. Like obviously from wood, iron is stronger, iron is hard, right? That is why we make the furnitures that is supposed to withstand ages, like the almirah and different all of these racks and all of these irons, not by woods, right? So that means what? Most of the metal they are harder than the woods and all those things, non-metal things. So that hardness is also a property of the metal, right? Or different material also, right? Depending on the hardness, you can actually differentiate between different materials. Got it? So what hardness is we have understood. Like now there are some metals that are soft in nature. Can you name any of them?
Which are soft. Um, a small silver chain, a
Silver
very
chain.
thin.
Silver chain is not soft. Can you break it by your hand?
No.
But there are materials that are very soft. Like let me show you some image. I'm not getting any image. Like there's, have you heard the metals like cesium, gallium? Have you heard the name of those?
No.
They are just similar kind of metal, just like irons and all of those things. Like the iron is very soft. If you take a solid iron, if you put in your hand, it will never go liquid, right? It will never turn liquid because it is hard, right? Now, if you take a solid cesium and place on your body, place on your palm, it will convert into liquid cesium. And the cesium that you can actually cut by a steel knife also. They are that soft, right? So generally most of the metals they are actually hard, but metals in some cases can be soft also, right? But general property of the metals are that what they are harder than the other counterparts, like other non-metal things like woods and bamboos and all of those things. The metals are generally harder, right? So that is also a very crucial property of the uh, different materials. Now another thing that you have it is transparency. What is transparency?
Transparency means when like glass it is very easy to see if we place means if it is an obstacle it is very easy to
The
see.
property of something or property of a material of allowing light through it or not. Is it allowing light to go through it or not? Say for example, this thing, this water bottle. You can actually see through it, right? Light is coming through it, light can go through it, can penetrate and come out of it. The plastic bottle also. These two things, both of them are transparent, right? That property of that these are allowing light to go through it. It is actually what? It is actually the transparency. Right? Some things cannot be transparent. Like take for example this book. Can you show? Can you see behind this book? Can you see my face? Because why? The
No.
light that was coming from my face can now not go through this book. It is blocking the light, right? So they are. It is not transparent to the light. And there are some things that can be translucent like glass. The light can go through it but it will bend in some way, right? It will make some differences, like how the light is actually going. So that transparency, that translucency, these are also different property for the different materials. Generally speaking, the metals they are not actually transparent generally. If you take a liquid iron or liquid gallium or copper or cesium whatsoever, even a mercury, it will shine. It will not actually allow light to go through it, right? So that is also a property of the the different materials. So most of the properties we have understood, like how these different things are working. Now another thing that you have it is solubility. What is solubility?
The ability of a substance to dissolve in water, and water is also known as universal solvent.
Universal solvent. Not only for water, like it is the property of a material to get dissolved in any other material. Like anything, but anything cannot be dissolved in any other thing, right? There are some limitation to how and what can be dissolved in any other kind of things. Like that is the actual property that we are calling the solubility. That everything cannot be actually dissolved in everything. Like a plastic cannot be dissolved in the water, but
Sand
uh,
also.
uh,
Sand also cannot be dissolved.
yes, and but there are so many things like sugar and salt. If you put them in the soil, it will dissolve, right? So there is a property of the materials that can dissolve in that thing. And after the dissolving process, what we get? We actually get the solution, right? And there are two parts of a solution. One is solute and one is solvent, right? If you take a glass of water and put a sugar cube, the sugar cube will ultimately mix completely in that glass of water, and you will be getting what? You will be getting a sugar solution, right? Now, in that thing, there are two in solution. There are mainly two different things: a solute and solvent, right? Do you know which one is solute and which one is solvent?
Solute means the thing which is getting dissolved in water,
Yes. The
and
solute means
solvent
yes,
means the mixture.
yes. Basically, if you look at the things, there are two different. Let me show you an image also. Uh, one amount is lesser in one thing is lesser in amount. Like say for example, we have a beaker. Just wait for a minute. It's not getting embarrassed. Okay, I think you can see. You have a beaker like
Yes.
that. You have a beaker like that where you have water and you have some blue powder, right? If you mix that thing, it will get blue. You will be getting a blue water, right? Now the amount of the water is much higher than the amount of this solid powder that you have mixed there. So whatever is higher in volume, higher in amount, we call it solvent. Where something is getting dissolved, and the amount of what is lesser, what is getting dissolved, what and where. Like what is getting dissolved, we call it solute, and where it is getting dissolved, we call it solvent. And the solute and the solvent, when they mix together, when they dissolve together, when the solvent dissolves the solute, we get what? We get the solution, right? So the solution, or the solubility, or the capability of mixing with something, it is also a property of the different materials of the matter system. Like the something, if it is mixed as quickly, we call it soluble. If it doesn't mix as quickly, easily, we call it insoluble, right? Or immiscible, miscible and immiscible. If it is mixed quickly or mixed, it is called a miscible. Like if you put this thing, the oil on top of the water, it will not be mixed, right? It will float on the water, right? So that is the property of the oil itself, and obviously the oil, it is immiscible or non-mixable or non-soluble or insoluble in the water, right? The chalk dust, they can actually be dissolved, right? So that is also a property of the matter itself. Now flotation, what is flotation?
Flotation. The ability of a substance to float on water, like plastic.
Yes. There are some things, if you not only water, if something, if put that thing on a liquid, maybe it is water. If it is lighter in weight, it will float. If it is heavier, it will sink. So generally, if you throw a penny, metal pen, it will sink. If it is a very small piece of plastic or this bottle cup, it will float. So depending on that thing, you can also group properties. Like we are actually learning different properties of different materials, how they different in different groups, right? So there is also a very easy thing, easy observable thing. Actually, we can observe. And state, we already discussed. What are the different states of some materials or any materials? What are the different states?
There are few states of each
Any matter.
material.
Like what are the three
Liquid,
states? Yes,
solid,
yes.
gas.
Liquid, solid, and gas. If something is solid, if you give it temperature, it will turn into liquid. If it is liquid, if you give it more temperature, it will turn into vapor or gas. If it is gas, you cool it down, it will get into liquid. If it is liquid, you cool it more down, it will get into solid. The very easy observation through which you can actually remember it always, it is the ice, water, and the water vapor. They can actually interchange between themselves just by applying temperature, right? Temperature difference. So by heating, that ice can convert into water, that is the melting, and the melted water can turn into gas, that is the steam, and that we call the evaporation. That is also a very important property of the material itself. Now, one other thing that you have, it is the conduction of electricity. You know what is electricity?
Yes.
What is electricity?
Electricity means from where we get the source of light in our homes.
Yes, it is nothing but an energy source. Like it can be coming from the battery, or it can be coming from our house's power socket, right? It is nothing but electrons. I think you have basic idea about electron, proton. If you don't have that, you will be getting that thing in the next class. No worry. But they are negatively charged, so they are, forget about those. It is electricity. Some materials can conduct electricity. Generally, all those materials that can conduct heat quickly can also conduct electricity quickly. If it is good conductor to the heat, generally speaking, they should be also good conductor of the electricity. Right? Generally, the metals, they are actually good conductor of the electricity, and that is why we actually have what we actually have. The metal wires. Most of the wires are actually made out of different metals. And what metals are actually used for making different wires?
Iron.
Iron is a thing, and also most of the wires, they are actually made out of copper, right? And in some cases, in some computers also, you need to use very pure quality metals, so that there is very less amount of insulation, right? And for that purpose, you actually use wires made out of bolts also, right? And have you ever seen a wire, electric wire?
Yes.
Maybe you can compare with that kind of wire. It is also a specific kind of wire. There is a conductor in one end made out of metal, and what it is actually protected by a plastic coating, so that when we touch it, we don't get a shock, right? We don't get electrocuted. So the plastic, it actually prevents the electric to flow to the outside from the inside, right? So the plastic is actually the insulator, right? So one that actually doesn't allow the electricity to go through, or prevents the electricity to flow, is actually the insulator.
Why are we advised not to means touch and means electric points with wet hands?
The wet hand, like the water, they are actually good conductor of the electricity. If your hand is wet and also you are touching the ground, if you touch the point, the electricity will flow through your body, right? And also what? That is not a big deal. Electricity can flow through our body. It is not a big deal. But why we get that pain? Because in our body, we also have our own electricity that is actually going from different parts of our body to our brain, right? Neurons, you have heard the name neurons, the nerves that actually helps to transfer different stimulus to our body. Now, when you touch that thing, the electricity also goes through that thing, and that actually mimics a pain. It hurts our body. Okay? So that is the reason that you are not supposed to touch the electric output through the wet hand. But there are, if you look at the electric output, there are 3 points or three round ports, right? 3 sockets. Like I also have a point that I can show you. Like there are these kind of things. There is one is on the up and two in the bottom. Like the up one is generally not very harmful. They're called the earthing, earth. Okay. It actually flows any excess electric current if there is a short circuit in the component to the ground, right? And one is ground and one is called the neutral. If you touch the neutral and that thing, live wire together, you will get shock. If your body touches the ground, you touch the live wire, you will get shock, right? So there are some principles like you can shape. There is something that you can safely touch the electric wire. Like that is how the electricians that work on the electric wire, they can actually touch that thing and they don't get electrocuted. Right? So that is also a thing. Okay. So that is there in your chapter, like I think 2-3 pages is not actually marked by you, right? So let's mark those. Like I will take the image. Okay, let's begin with this one.
Okay.
Now the you open that page 66.
Yes.
You read the activity yourself and tell me what actually happening. You will explain me to that.
Aim to classify the given materials as magnetic or non-magnetic. Materials needed pins made of metal, clips made of plastics, pencil, eraser, water, glass, cardboard, comb, nails, iron key, rock, swing needle, paper and magnet. Bring the magnet near to the objects by one. Observe which objects are attracted towards the magnet, which are not. Prevention, observation, pins, nails, keys, and swing are attracted to the magnet. Eraser, clips, pen, water, comb, rock, glass, cardboard, and paper are not attracted to the magnet. Conclusion: some materials are magnet whereas some are non-magnet. Means here it is told to for a magnet can means be attracted to the iron.
Not the magnet. Actually, the irons they are attracted to the magnet. Have you seen a
Yes.
magnet?
Yes.
Which kind of magnet you have seen?
The magnet which means stick to the fridge.
Like how big was that?
Huh?
How big was that?
In the size of this much.
Okay. You know there are some magnet that is so large that can actually lift entire cars. Okay. Magnet can be such big also. And see the magnet that in your book, the image of what magnet is given, it is called an U-shaped magnet. Okay, because it is just like a U. Right? And some magnet they are actually like normal stick. Okay, so the magnet can be of varying shape. Okay, and they have two different poles. You know,
Yes.
what are the poles?
North and south.
North and south pole. If you put two magnets each other, North Pole facing together, what will be happening?
It will be attracted to both.
No. The same poles, they will repel each other.
What are magnets made up of?
They are made out of specific, like they are specific type of metals. Like the magnet we use, whatever magnet you have seen, they are called the neodymium magnet. Okay, they are made out of special thing. Like uh, let me show you that. This material that you can see now, it is called the neodymium, right? And it is a material that is naturally have that property to attract. Okay, it attracts other magnets and also the metals, right? The iron specifically. That is how the magnet is made. And now the same poles, the north pole and the north pole of a magnet will repel each other. It will do that. The south pole and the south pole they also do that. But the north pole and the south pole, the opposite pole, they will attract. And any pole of a magnet, you take that with close to a this metal, it will attract, right? Right. Now that in that experiment, in that activity, what you are doing, you are having a bunch of stuff of lying on your place. You have a magnet on your hand, and just by using the magnet, all of those things that is actually getting attracted to it, that magnet is nothing but what? It is nothing but iron. Right. So by their magnetic property, by the property of magnetic attraction, you can actually separate the things. Now that was actually you are doing. So okay, let's do what we are doing, like marking things. Let me take that here. Okay. See where I'm marking. Okay. Like what is why magnets are called magnetic material? You need the property of magnet is what? Magnetism, that you need to know. Objects made with iron are attracted to magnet. It is also very crucial. Iron, nickel, and cobalt, they are also attracted to the magnets. Right. And do you know somewhat at some level, at least very feebly or very poorly, human body also attracted to the magnet. Can you tell me why?
Because our body also contains the water.
Not water. Water doesn't get attracted to the magnet. Iron gets.
Um, Iron.
In our blood, we have hemoglobin, right? That makes our blood red. And that hemoglobin, in the hemoglobin, we actually have iron, right? That iron can actually get attracted to the magnet, right? So the human body is also familiar or very poorly attracted to the magnet. There is an experiment you can also find in the YouTube that some scientists was floating a very small frog in a magnetic field, right? So that is also that you must remember. And the conduction of heat, okay, what is conduction of heat? That portion you need to uh, mark down, like why the handles are made out of plastics or non conducting things. Water conductors you need to understand, and also water insulators you need to understand. Okay, so let me remove it and take the next page. I think some pages are randomly arranged here, so no worry. That is the page. Yeah, this one. That is, I think, slightly marked. Okay, let me complete it. What you mean by rough? That thing you underline. Broad, circular, what is smooth?
Done.
There, in the that thing, that solubility, there is a also very important thing given that water can also dissolve oxygen, right? And that is the reason that the aquatic animals like the fish and all of those things that actually live in the water, they can actually get oxygen from the water itself. Like the water, the how we get the oxygen, from where we get the oxygen, we get the oxygen from the air. But the fish cannot breathe there; they have to get the oxygen from the uh, what they live or the water itself. So that is how they actually get the oxygen from, right? Because the water can actually dissolve the oxygen, right? Now, if it's a water, bottle of cold drinks, if you open the cap, what happens? It freezes up, right? Why that
Yes.
thing happens? Because the cold drinks or the whatever that thing is, Pepsi, Coca Cola, whatever that is, they are the carbonated water, carbonated soft drinks. Because by pressure we dissolve huge amount of carbon dioxide. When you open the cap, the carbon dioxide that was dissolved in the drinks, it comes up. That creates the freeze. Right? That is also written.
Means all the types of juices we drink, all of them are made up of carbon dioxide.
They are not made out of carbon dioxide. Like the soft drinks like Coke, Fanta, all of those cold drinks, not the juices. Where there is a fizz in them. Fizz, the small bubbly thing, right? So those cold drinks, they have dissolved carbon dioxide. They are not made out of carbon dioxide. They are made out of, the main component of that thing is sugar and water and some flavors that give its particular flavor. Like in Pepsi, there is a flavor. In Fanta, there is a different flavor that gives its characteristic flavor. And for the fizziness and thing, for that purpose, huge amount of CO2, carbon dioxide, it is actually pressured and mixed and dissolved in the water. Right. And there is a also there is another thing that is in the that cold drinks. It is phosphoric acid. Okay. Something.
What? Why does means if we add Mentos in Coca Cola means it
It comes out.
bursts?
When you put the Mentos, it actually does a chemical reaction that releases all the carbon dioxide that was dissolved in the water. And just at once it comes out. Right? It is equivalent to if you just putting the cap and doing that thing and open, it comes out, the same thing also happening there. Let me remove it. Okay, what is transparent and what is translucent? You have to remember what is transparent, what is translucent, and what is also opaque. And these examples you remember which one is which. State you have to remember. And this chart is very, very important, like the difference between or the comparison between the three states of matter. Right. But there are other states of matter. Right. The only states are not liquid, solid, and gas. There could be other states of the matter. There is a fourth state of the matter called plasma. Right.
What matter?
There is a fourth state of the matter. The first state is solid, then the liquid, then the gas. There is also another state of the matter that actually can take place only in very, very high temperature. We call it plasma. Right. The sun is actually in that particular state because obviously what the sun is very hot and that hot temperature the sun is made out of mainly hydrogen and helium. The hydrogen and the helium cannot be remain in the form of gas at that particular temperature. They become a plasma, the fourth state of the matter. Right, that is why they actually glow. And electrical spark, like when there is a thunderstorm, that spark that comes from the sky to the ground, right? It also creates plasma. Okay, at high temperature and high electricity, all of those things. You have marked those?
What?
You have marked this page?
Yes.
Maybe the last page of this chapter. It's electrical conductivity is. One more thing that these keywords that is very important. You can get lot of questions. Examples you need to remember which one is conductor, which one is insulator. You need to remember the examples of those. Okay. Well, so let's start with the exercise. Sixty-eight number. Question number one. Read the question. What is the answer?
Glass sheets and these are the answers are written.
Okay, no problem. Then also we will be doing that just for practice.
Glass sheets and flower petals are example of smooth surfaces
Why will you call it a smooth surface?
because they when we touch it means a buttery substance comes.
Yes. They are not very rough. They are not very coarse to touch.
What is the meaning of glass sheets?
Glass is a sheet of glass, like glass comes in a rectangular shape, right?
Yes.
That.
Dash materials can be compressed easily. Soft.
Like, can you give an example of a soft material?
Pillow.
Like it is an object. What is the material it is made out of?
Cotton.
Very good. Like now you have understood what do you mean by metals, not metal. What is materials and what is object?
Yes.
Cotton is the material that is used for making the pillow. By using the cotton, you can also make all other different. Even a soft toy you can make with that, right? So that is how these two are different. Okay. Next one.
Dash materials that allow sunlight to pass through are them are called dash. Transparent.
Transparent.
No
Transparent or translucent?
um, translucent.
How these two are different? Transparent and translucent.
Um, no translucent only because transparent allow light.
Transparent allow 100% of the light to go through that. Translucent actually allows some light to go through it, and like there are some different kind of glasses in the window. Like some window glasses allow everything to see. It is a see-through glass. Some it actually makes the picture hazy, and some are what it makes the complete picture blurry. Right. That is a transparent, translucent, and opaque. Yeah. Next one.
Dash are highly compressible gases.
That are highly
Compressible.
compressible. Yes. Gases. That is also when you compress a gas, what it becomes?
Means it gets invisible in air.
No, it will not get. It will when you compress a gas very much, it will convert into liquid.
Okay.
Have you seen a cigarette lighter?
Yes.
There is a liquid inside it.
Yes.
That is actually gas. That is in very high pressure. And for that purpose also, the gas by what we actually cook, we call it first LPG. We call,
Yes.
and the full form of LPG is called liquefied petroleum gas. A gas in high pressure it is liquefied.
What is the difference between red color gas cylinders and blue color?
These two are actually they are similar. They have difference in their capacity. One is almost 17 kilogram, one is 19 kilogram. The red color we use in the home, and the blue color one we actually you meant to use in the shops and commercial places like restaurant and all those things. But the gases are same inside. There are many two different kind of gas you can commercially get. Like there is LPG through which you actually cook, and there is called CNG through which actually the auto they run. Right?
Okay.
They are called the compressed natural gas. Slightly different in their formula, but generally both of them are gas, and by burning them you get the energy. Next question.
Liquids that do not dissolve in water and called dash water. Immiscible.
Miscible water or insoluble. Okay. Next question.
Which of the following has a rough surface? Sandpaper.
Sandpaper. Have you seen a sandpaper?
Yes.
They are used to, you know, rub things to make them smooth. They're very coarse and they come in different coarseness. So
When we means rub any type of wax in sandpaper, it turns into powder.
yes, it actually makes it very fine grain. Some sandpapers are meant to sand only the metals. They are very hard grain. Some are meant for polishing only the wood. They are softer than the first one, right? So there are different grades of sandpapers. Next one.
Which of the following can be compressed into small extent? Liquid.
Why not gases?
Because gases floats in air, we cannot catch it.
You can catch it. It is the question is saying what can be compressed to small extent. Like it is compressible but not that high. Like you take this amount of gas and you can compress it to very small thing. But the liquid can, if you take that liquid, can be compressed to that only. Right. So liquid can be compressed but not that high. That is the question is what it is saying. Right. Okay, next one.
Which of the following is translucent? Translucent.
Translucent is
Um,
the second one. Like that actually allows some light to pass through but not all.
what is cellophane paper?
Those plastic papers you haven't seen. Those used for wrapping things.
Yes.
That is cellophane paper.
Which of the following is a characteristic feature of solid? Um, its particles are closely packed and it has no definite volume.
It has definite volume. Definite volume that means what? If you the I don't have a example here. Like say for example this one, it has a particular shape, size, and it takes some space. That is actually volume, right? It has particular volume, but the water, you take the same water, you put that thing in a glass, it will take a shape of the glass, and that it is talking about. But that sorry, they have all those properties. They have proper shape, proper size, proper volume, all of those things. But what they have, that property that is mentioned that their molecules are very tightly packed. You cannot actually compress a solid very much. Because there are so less amount of space between each of the molecules that makes up solid. Right? It cannot be compressed anymore. It's the most compressed form of a particular matter. Next one.
Which of the following is insoluble in water? Wax. But carbon dioxide can be.
Carbon dioxide can be soluble in the water. Like in the soda water or the cold drinks that you have just discovered, we are dissolving the carbon dioxide. That means what? Carbon dioxide can be dissolved. That means solid
Which
body.
of the following is a conductor of heat? Metal.
Metals. Anything that is conductor of the heat, it's also conductor of the electricity as well. Right.
Which of the following states of matter has close packing of particle?
Yes.
Solid state.
Solid. Solid. There is a most closely arranged condition. Next one.
Which of the wood materials will sink in water? Wood, rock, leaf. Wood. Sorry, rock.
Rock. Because it is heavy. It will not float. Let me grab the
Is
next.
wood a kind of metal?
Wood. No. Wood is not a metal. How we will understand wood is not a metal? Do wood shine?
No.
Do wood transfer heat very quickly?
No.
Do wood get attracted by the magnets?
No.
Do wood sink in the water?
No.
That means all of the metal properties are not there in the wood.
In the means soil plants grows so underground the copper, diamond, all of those are found underground. So are those things living?
No, they are not actually living. There is a very fine line between what is living and what is not living. Like if you look at the nature, if you look at the ground, both of them are actually made out of same things of us. Like they are also made out of carbon, hydrogen, nitrogen, oxygen, phosphorus, and all of those things. All of the natural materials, all of the natural matters that makes the airs and the soils and all of those things, the diamonds, all of those things. We are actually a very integrate part of this earth, right? But whenever we are talking about ourselves, when we are talking about our cells inside the cell, they are arranged in a way, they make up the cell in a way that they will show some property of life itself, the property of like excretion and the reproduction and the stimulus response and all of those things are all already discussed in those chapters. Right. So where actually non-living things or the abiotic things ends and where the biotic thing begins, that thing is not actually very clearly known. It is also a very unique thing to debate about, right? Say for example, virus. They are actually in between this non-living and the living things. Inside some host, it will behave as biotic things and as a living organism. But just outside, they will be just like a single particle, simple particle. It will float in the air, it will float in the water, it will not do anything, it will not reproduce for very long periods of time. Like there's a very small difference between the biotic and the abiotic things. But long story short, to be clearly said, the soil and all of those things that you have in the under the ground, they are not living, but somehow they make the life. They make a component of the life.
Next is
Okay, next page. Let me grab it first. Next page. Next page. I'm not finding. Next page. I'm not finding. Next page. I didn't found that. Let me take it. Mm, Power from motion and movement. That can not from this chapter. Okay. Let's grab this thing. Okay, whatever there is there. You have understood what it was done there.
yes.
Tell me what you have understood.
State it is given different types of states, solid, liquid and gas. In transparency it is also given transparent, translucent, and
Like,
opaque.
like what you are doing there. There, what you are doing. This part.
Here, how many types of matter?
What are the different? Not how many types of matter you are not doing. You are actually doing properties of matter. Different properties of matter that we need to understand. Roughness you have understood.
Yes,
It is a property of the matter. It's not type of a matter, right? Type of a matter means wood, metals, and these are the types of the matter. Property means that luster thing, that floating thing, that solubility things, all of those. These are the properties of the matter. That properties are different in different types of matter. That is what written there, right? Like luster, you know, that shininess, magnetism or attraction of the magnet, you know, hardness means compactability, you know, transparency means like uh, flowing of light through it, you know, state means solid or liquid or gas, you know, solubility means if it is, it can be dissolved in the water, that you know, flotation means it can be floated on the water, that you know, like these are the different properties of it, and if there are different three stages, different three kind of transparency, different type of solubility, and different type of heat and electricity conduction, right? So these all are the what? These are the properties of the uh, matter itself, or the material itself, right? So let me grab some questions for you. Can you see the questions?
yes.
Let's do it.
Objects are made up of a large variety of means objects,
Objects are
metal,
not metal. Objects are made out of what?
wood,
They are what?
metal,
They are what? Like pillow was an object, and the cotton was a
cotton was the material.
material or matter. Okay. Next one.
Um, tumblers are made with materials that. What are the meaning of tumblers?
I have to show you image. Like those are glasses. Let me grab a good image. Like this one. Okay. Tumblers are made with material that can hold. What kind of things you put in that kind of glass or cup?
Glass,
Like
metal,
what do you know? What inside the glass you actually hold?
inside the glass, any kind of liquid thing.
Very good. Liquid. Liquid you are holding. Not solid, not gas. Right? Liquid. Next question.
Materials that have luster are usually called as jewelry.
Metals you can say. But there is a English term like all glitters are not gold. That is also true. Some non-metals can show luster, but they are not metal because they will not show other properties of the metal. Next one.
Three example of metals are iron, Nickel,
Okay.
cobalt,
Okay. Next one.
the gas which can dissolve in water, carbon dioxide.
Okay. Okay. Next one.
Materials are grouped together on the basics of dash and dash in their properties.
No, that could be multiple answers for that question, right? Uh, on the basis of what should we say there? Okay, leave that question. We'll check that thing. Next question, say question number 7.
Some metals lose their shine and often look dull because of the action dash and dash on them. Because if they are wet,
If they're wet, then what is doing the action there? The water and
yes,
also
it is
oxygen.
becoming kind of like glass, hazy.
Yes, the metallic shine is actually gone, right? So we call it oxidization. Okay, the term for that thing is called the oxidization. The oxygen that is in the air and also the water vapor that is in the air that actually change the metal, right? Interact with the metal. Right? Next one.
Based upon transparency, material can be grouped as dash and dash. Glass,
Transparency, three type of transparency, three type of light passing thing.
opaque,
Yes, and
and translucent.
and
And transparency.
no, transparent, translucent,
Trans-
opaque. These three things. Okay, name the following.
Two liquid soluble in water. Liquid. Honey,
Okay, and
lemon juice.
yeah,
Two liquid insoluble in water. Oil and
give me example of two oil that also do.
white oil and cooking oil.
Like kerosene, you can say kerosene is a oil, petrol is a oil. Next one.
Two transparent objects. Glass and plastic. Two translucent objects. Design glass and
A paper white in oil,
okay, the butter paper.
butter.
And two opaque objects. Wood and book. Two solid soluble in water. Salt and ice.
Ice. Okay, you can say ice. No problem. Ice is a tricky one. Yes, you ice you can say. No problem. I will accept the answer.
Um, right,
But
true
but
or
see but
false?
see. What is the problem with ice? Because uh, obviously same things can be mixed with same thing. Right? Ice is nothing but water that is solid. You're mixing
Yes.
solid water with liquid water. So technically you are right. Technically you are very right that ice is a solid thing that can be dissolved in the water. But maybe some teacher will not accept your answer. Maybe. But you are technically 100% correct. You know? I like that answer. Like ice is a thing that can be dissolved in the water. Okay, next one.
Stones and nails float on water. Stones does not float, so false.
Yes.
Cotton is soft while iron is hard. True. We choose a material to make an object depending on its property and its purpose of usage. True. Define the following. Transparent materials. Transparent materials are the materials which allows light to pass through it. Translucent, which allows very few amount of light to pass, and opaque, no light can pass through it. Distinguish between soluble and insoluble. Means I will differentiate.
Yes.
Soluble substances and insoluble substances. Soluble substances cannot means be dissolved in water. Can be dissolved in water, and insoluble substances can't be dissolved in water.
Next one.
Answer the following. Why do we need to group materials? Because different things need different kind of metals.
Kind of. Like the actual answer should be kind of like this one. Right? You can see the text.
Yes, we
Write that.
need to
Write
group
that text.
materials
Write it.
so that we can sort out among the different materials and study about their properties.
You write that thing in a book.
Done.
Next question.
Um, which one? Name any four properties that can be used for sorting materials. Means I did not understand.
Depending on which four properties, you will be differentiate between, say, for example, metals and woods. What properties you will be choosing? Like one property could be the transparency. And tell me other four properties.
Um, Transparency, floating in water or not
Okay.
floating in water.
That is also another.
Their shininess.
Okay, another one. That is luster. Term for it actually luster.
Okay, luster and how they look.
No, how they look is not a property.
Then their weight.
The state you can do. If it is solid or liquid, that I can do.
And if they are translucent.
There is the transparency you can choose. Or the heat conductivity you can choose. Electrical conductivity you can choose. So all of these are different properties through which you can actually differentiate between all of these things. Right. So you can do the questions, right? You can actually solve it. What else we have? Let me see. Your copy. That. Okay. I guess almost all the um, important things from this chapter is also done, right?
Yes.
Okay, the exercise is also done. So what we will be doing will be uh, solving, not solving, we'll be solving the, yes, we'll be solving. Have we solved the exercise from the measurement chapter? Measurement, and from that chapter the exercise is solved.
Measurement.
Have we done that thing in the previous class?
Measurement.
The physics chapter. Is that done?
MC.
Okay, interesting.
No.
Okay. So next day, like next Wednesday, we'll be doing that. Okay.
Okay.
Do you have any questions you want to ask me about anything?
No.
Nothing. Check you have any questions, like anything from the previous chapter or this chapter, or any other questions that will come in your mind. Okay.
Is our hair means a living thing?
Which
Are
one?
they
Which one?
made up of cell?
Which one?
Hairs.
No,
Hair.
hair are not made out of living cells. The hairs and the nails, they're actually some proteins, the keratins, right? Our living cells on the skin, on our scalp, and the fingertip, just beneath that thing, they produce that thing and it protrudes out, right? It is just like a protecting things on our body. They itself are not living, right? Like they are equivalent to the horns of the cows and the goats. Like they are also not living. They are the part of us. We are living, but they are not. That is also a very unique thing. They are made out of some proteins and medicine. So if there is no problem, then
No.
done for today. Okay.
No.
So bye. We'll meet in the next
Bye.
class. In the next class, we will be discussing this.
You will give homework.
You want to get homework? Okay, you do one thing. This chapter homework, this chapter exercise, all of those things you can do by yourself.
Measurement and motion.
Yes,
Okay.
all those things that is actually not done, it is you can actually done by yourself. If you get any
Yes.
problem, any trouble with any question, you can ask. Right.
Okay.
So that is the homework. Okay, nothing else.